This is a video of the integration of diffusion tensor imaging, or DTI, with the NeuroNavigator. Currently, we're looking at the 4 view. We can look at other views: axial, coronal, sagittal, the 3 view for all slices. For now, I'm going to look at the volume view. This is an individual who was struck with a bat. He was assaulted in the right parietal region. He has spatial neglect. He does not shave the left side of his face, nor write on the left side of a piece of paper. He's paralyzed to a fair extent on the left side. That's the z-scores from the electrical potential, which is at the maximum. Here is 4 standard deviations from normal. In any case, and you can see the distribution of the z-scores on the right parietal lobe related to his injury. We can make the scalp transparent here under this control. I'm going to just quickly show you the controls. This is object. You can hide these controls. You can activate controls. You can go to a full screen. And right now we're in objects. We can look at different data types, Laplacian. Here's the Laplacian. Here's the electrical potential. In connectivity, we can look at phase differences, lag coherence, information flow, and we can change scales of z-scores or raw scores. I'm going to go back to objects, and I'm going to make the scalp now transparent. And I'm going to go to the 4 views and drill down so that we are a little easier to see the things I want to look at. And right now I'm going to take off the diffusion tensor imaging. Just to give you the landmarks, this is the z-scores at the surface. We can change this to go to the, that's deep in the brain. We're going to go now to the surface. And you'll see it gets dark because there's dura, there's no electrical potentials there. I'm going to go back down to the deeper parts of the cortex, and there's 10 steps you can go through to see that. Now what we're going to do is look at diffusion tensor imaging, and in order to do that, we need to make the skull, the scalp certainly transparent and the cortex transparent. I'm going to move the cortex so it's transparent. I'm now going to select diffusion tensor imaging DTI, and these are the bundles. We have currently 8 bundles. The left and right posterior, or left and right corpus callosum, the left and right occipital temporal fasciculus, the right frontal corona radiata and left frontal corona radiata, and the left and right uncinate fasciculus. We can select or deselect these as we wish. These are different bundles. There's a number of others that we're going to be putting in, guided primarily by the Catani and Deschatten Atlas. This particular view you see is available in the free NeuroGuide demo, so anyone can download the NeuroGuide demo and do what I'm doing. Now, these diffusion tensor imaging bundles show the actual connectivity. We can superimpose the connectivity of the fiber bundles connecting different parts of the cortex, but they're spread out. For example, this is the radiata, corona radiata, but we can superimpose, if we wish, the Brahman areas and the functional connectivity. And in the future, we're going to have functional connectivity of the diffusion tensor imaging itself. We'll be able to look at coherence, the colors will change, we'll be able to look at phase differences depending upon the deviation in degrees or z-scores. The colors will change of these various bundles. We'll also add bundles, and we will be able to also look at effective connectivity, which is the magnitude and direction of information flow. And we'll be able to change the colors at the ends of the radii of the various bundles, depending upon the magnitude of information flow or the direction of information flow, and the z-scores, the deviation from normal. Right now, we're just putting in the structural diffusion tensor imaging. But we can superimpose that even now with the functional aspects by looking at the center voxels. I'm going to click on center. Those are the center voxels. This happens to be the attention network, dorsal attention network. I'm going to go back to bundles. And I'm going to now add connectivity. In this case, the default will be coherence. And you can see how the Brahman areas correspond to different bundles and where they're located on these bundles. In this case, we are looking at the, we can tell which, I believe this is Brahman area 9. You simply right mouse click, hold the shift key down and right mouse click, and you can get with this Brahman area. This is Brahman area 9 left. Here's Brahman area 9 right. You just click anywhere outside of that and it will erase that. This is Brahman area 8 left, Brahman area 8 right, and I'm going to get rid of it. So that allows you to look at different aspects and different networks as it relates to the diffusion tensor imaging bundles. We can go to networks and we can change this to the default mode, for example. You can see the relationship between the terminal ending points and the default network. For example, this is one that's involved, and that's the Brahman area 19 right, which is part then of the occipital temporal fasciculus. One can also add planes to this if you wish. You can move the planes up and down. Gives you some idea of where things are with respect to landmarks. You can add a coronal and sagittal plane if you wish as well. And you can move all of these around. We can, under navigation, can look at the bottom of the brain or the top of the brain. We can look at left and right. Etc. And get different views and different landmarks. And the coordinates, of course, are up X, Y, and Z, telegraph atlas coordinates. The maximum Brahman areas are shown both in the upper left here and over in the lower right. Z-score scales and raw scores or whatever you wish, whether it be raw scores or Z-scores, you'll be able to select or see by playing around with these items here. You can tell by the colors which values are present. But there's the right parietal lobe problem that this individual has. And here are the fiber bundles that are part of that to give a more complete view of the brain and its connectivity. As we move on, I'll make the scalp and the skull transparent. I'll remove the connectivity and just look at the fiber bundles. So there's a lot of tools in here to explore, to be able to evaluate different aspects of the brain in patients with different problems, and link the patient's symptoms to dysregulation in hubs and nodes and connections between network hubs and nodes. So I'm going to terminate this video, and thank you all for watching.